All right, so we're going to talk about constructions today, but before we talk about constructions, we have to cover some definitions. We already have some definitions, so we got some more to write down though. So I have my trusty composition book here with all my notes. You should have a composition book as well. So we're going to do some more definitions. So these are more definitions. First definition we have is coplanar. Coplanar. Coplanar, the definition of that is points and lines that lie in the same plane. So in the same plane. So for example, if this piece of paper right here, I can think of this as a plane. All right, and I can take a little segment of it. So if I have 3 points in a plane, let's say A, B, and C, those 3 points are coplanar. This whole piece of paper is a plane, right? So if I could put some points here, 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 these would be coplanar. They are along the same plane. It also works for lines. If 2 lines are in the same plane, they are called coplanar. So these lines, let's say those are in the same plane, well, those are called coplanar. So we have coplanar. There's also something called collinear. Now, collinear. Collinear is points that lie on the same line. So if I have points that are on the same line, we call that collinear. Let's see, for example, here's a line, and I have my arrow, so I know it's a line, not a line segment. Now, I could say that points A and B are collinear. I can throw in another point. I could throw in point M. I could say A, M, and B are collinear because they lie along the same line. Those are collinear points. And the last thing I want to get with, now that we know collinear, coplanar, I want to talk about parallel. Parallel. So parallel means lines that lie in the same plane So lines that lie in the same plane but do not intersect. And let me move the camera down just a bit here so that you can actually see this. There we go. Don't be afraid to pause the video whenever you have to. So parallel means lines that lie in the same plane but do not intersect. So, for example, if I have a line here, I have a line here. Notice how these 2 lines are in the same plane, which is my piece of paper, and also they do not intersect each other. That's called parallel. And just remember, they have to be in the same plane. For example, pretend my pen is a line. It's kind of hard to see it 3-dimensionally. But I have my pen, it's above the paper. All right, so it's above the paper. So this line right here is not in the same plane as these 2 lines down here. So this line cannot be parallel to these 2 lines because there's no plane that could actually go through these. Now, I could face it in the same direction like this, because then I could draw another plane, or I could show a plane here. I can get a piece of paper and show you. I can make another plane that connects this with this right here. All right, so that's parallel. Parallel means they have to be in the same plane. And I got to think about how to make that a little clearer. I still don't think that's clear, but I'm going to have to get back to you on that one. Again, parallel, two lines that lie in the same plane but do not intersect. That's parallel lines. All right, so let's see, what else do we have here? So we have our definitions. One more thing I have to go over. That's going to be our first major postulate. And we have a special name for it called segment addition postulate. And whenever I say postulate, I always like to put in parentheses axiom. And again, the reason for this is that geometry is a very small piece of mathematics. It's a very small piece of mathematics. And in most other branches of mathematics, we call these axioms. Geometry is really one of the few, if not the only one, that actually calls those postulates. So I want you to get in the habit of knowing that a postulate is the same thing as an axiom. I mean, there's the same thing. It's just postulate is a little special word we like to use for axiom in geometry. So we're doing the segment addition postulate. If I can't get that camera looking right. For some reason the video is lagging. We'll just move on with it here. Okay. I think that works. No, that doesn't work. Let's try it that way. Okay, there we go. All right, so segment addition postulate. We'll use A, B, C. Let A, B, and C be collinear, because we know what that word means now, don't we? Collinear. So these are collinear points. If B is between A and C, then, and this is important, AB plus BC equals AC. So let A, B, and C be collinear points. So I've got 3 points that are on the same line. If B is a point in between A and C, then AB plus BC equals AC. So as a picture, let me show you what this looks like as a picture. As a picture, we'd have something like this. We'd have, let me draw a line with 3 collinear points. Actually, we want a line segment, don't we? So let's make it a line segment, because it's segment addition postulate. Not line addition postulate, but segment addition. Line addition wouldn't make sense because lines are infinitely long. So we're talking about line segments. All right, so let's let this be A, this is B, and this is C. All right, so I got A, B, and C. Now, this line AB, or line segment AB, plus line segment BC is going to equal line segment AC. Pretty obvious, right? It's pretty obvious. And we're actually going to show this. So in the next video, we're going to use our compass to actually show how this works. So that is the segment addition postulate. Make sure you have that. And before I sign off on this first video, I want to let you know that it's a good idea to try and have a second composition book for postulates and for theorems that you've proven. Because when we start doing proofs, you're going to have to refer to postulates and theorems. Because remember, whenever you make a statement, you have to make a justification. So those justifications are the postulates and the theorems that you've already proven. So it's kind of nice to have those together in one spot. So if you can, I would strongly urge you to have a second composition book. I mean, you could fit it into one book along with your notes and everything. I mean, you could fit it into one composition book, but it's a bit more back and forth than you really have to do. If you had it in a separate book, it's kind of easier to reference. So really having a second composition book is really a better alternative. So I really want you to think about that. And if you did have that second composition book, this would be the first thing you write, segment, addition, postulate. All right, so now we're going to move on to constructions with a straight edge and a compass.